Okay, so everybody can see my screen, right? All right, so simple equations, let's start with that, right? And then we'll go to inequalities. But in both cases, you basically have to find for one unknown. And usually, right? I should say usually, in every case, that one unknown is, it takes on just one value, right? One value. The equation would basically not have a power in it, right? So let me give you some simple example. You know, let's say you're asked to solve something like this, 2x plus 1 equal to 5x minus 3. So you have one unknown, even though x is both sides. Uh, x is a single unknown. It's just a matter of getting them together and solving for x, right? Or finding the value of x that would satisfy this equation here. Right? You can have, let me just give you a couple of types that you can see. Let's say you have something like this. That's a subtraction sign. Something like that. You can have equations involving fractions too, like you can have something like that, right? So yeah, you can have fractions, you can have something linear looking like this. You can have something that involves some brackets and so we'll look at all the various types. And then we'll talk a little about inequalities, right? Well, inequalities basically, well, we deal with linear inequalities too, right? So, just like these here, you might have 2x plus 1 is greater than or equal to, 5x minus 3, right? All you gotta do is change these signs, maybe, okay. We go with less than 4, down here, you can put greater than or equal to. That's the kind of thing you'll see, right? When it comes to inequalities. So basically, we're going to talk about how to solve them very simply. And then at the end, we'll talk a little about solving word problems, right? Word problems that might very well give rise to simple equations, right? So we'll take them little by little. Good. Um, so let's start with some simple equations, right? And basically, let me give you an example and I'll explain how you go about solving them, right? Let's say you have to solve something like this, something as simple as x plus 2 equal to -1, right? So basically you have to solve for x. What value of x would make it such that when you add 2 to it, you get -1, right? And one of the comparisons or the analogies you see in all the textbooks is that you want to think of an equation like a balance, right? And for you to maintain the balance, what you do to one side, you must do to the other side, right? That's a simple approach to solving any equation, right? Nothing very difficult. What you do to one side, make sure you do to the other side, right? So let's take this one. So you want to get x. So you want to get this 2 out of here, right? So what you could do is subtract 2 from both sides. Remember, you can't do it to one side and not the other, right? So this 2 minus 2 becomes 0, and you're left with x alone. X then is equals to minus 3. And you finish there, right? I know in the textbooks and so sometimes you see and teachers will tell you that you can take the 2, what they say, they take the 2, take the plus 2 and bring it over here, and it becomes minus 1, right? Change plus to minus, right? And the teacher says you can write x equal minus 1 minus 2. X then is equals to minus 3, right? While this is, huh? Somebody is asking something.
Yeah,
Yeah.
good afternoon. I was thinking it the same way too, the same one that you put in the bracket. I was thinking it like this too as well.
Okay. However, right, from a purely mathematical perspective, right? There's no what mathematical operation is this? Taking this two over there and changing sign and all that. There's no mathematical operation like that, right? So while you know it's accepted, it gets the job done, you get the answer, right? It's just what do I say? It's like a way of getting the answer, but it's not purely mathematical, right? You can do it, right? You can do it like that, no problem, right? But I was telling a guy, I'm doing a course with a guy, um, and the course is what you call mathematical analysis, right? And I was explaining to him that in this course, don't try any shortcut, right? Everything must be, 100% mathematical, right? And something like this will not be accepted in a course like that, right? Because as I said, there's no mathematical operation that tells you can take over this over there and change this thing. It's just a shortcut that people observe that it works, right? And you get the answer and everybody accepts it. But it's not a purely mathematical approach. What we did here is purely mathematical, right? Because here, because you have a certain balance, right? And you subtract the two from both sides, it maintains the balance and it gets you the answer, right? But this here is a purely mathematical approach. But as I said, even me, and in this course, this will be tolerated, right? It will be tolerated. So if you do that, no problem. You will see eventually, I might very well, I'm not going to show you all of this here, and I'll just watch this thing and write this and tell you the answer, right? In time. But it's very important for you to understand where did this shortcut come from? What is it that we are in effect doing? And this is what we are in effect doing, right? We are subtracting 2 from both sides because we want the x isolated on one side and everything else on the other side, right? And for us to do that in this case, we have to subtract 2 from both sides. Remember, an equation is seen like like a scale where the amount of produce inside the pan equals the weight on the other side, right? So if you want to maintain that scale balance, whatever you do to one side, you have to do to the other side, right? To maintain the balance. Good. So let's take some more examples. Okay. Let's say you have something like this. 5 minus x equal to 7. All right. So you want to get a value of x. What will the value of x be? That when you subtract it from 5, you get positive 7. Again, you think of it as a balance. What you do to one side, you do to the other side. And there are more than one approaches that you can use to to solve something like this, right? So one way you can do that, okay, you can take 5 from both sides, no problem. So you can take 5. Some people put a minus 5 at the end here, but you can put it right here. 5 minus x equals to 7 minus 5, right? So this 2 will go, you're left with minus x equal to 2. But you haven't found x yet, you have minus x. So what you can do then is multiply both sides by minus 1. And what do you get? You get positive x because minus x by minus 1 gives you positive x is equal to minus 2. Right, that's one approach. Another approach, maybe I can slide this down right here. Another approach is that you can take, okay, 5 minus x equal to 7, right? And add x to both sides. So you get 5 minus x plus x equals 7 plus x, right? So I added x to both sides. So over here becomes 5 equal to 7 plus x. And then we take 7 from both sides. So you got 5 minus 7 equals to 7 minus 7 plus x. So this becomes minus 2 equal to x, which is the same answer, right? The shortcut that you are accustomed to, let me just, I'll borrow this piece here. Okay, maybe I'll go here. The shortcut that you are used to is this. You know, a lot of people do this. They say, take the minus x over there, right? Change minus to plus. Okay, so you get 5 is equal to 7 plus x, right? And then you take the 7 over here, right? And of course, the plus sign, plus the minus, right? So you change it, you get 5 minus 7 equals to x, minus 2 equal x, right? If you want to write that back, x equal minus 2, that's up to you. So that's a shortcut, you know. Following so
Yes,
far? Somebody was going to say something?
I was saying yes, sir.
Okay, good. All right, so let me go back here. Then you can have, all right, let's say you have something like this to solve. X minus 2 equals to, all right, before I go to that one, maybe let me do a couple with um, products and so on. So say you have 2x equal to minus 3, right? So you have a product here now. You're not going to subtract now, you're going to divide now. So you divide both sides by 2, and you get this. You get, well, these 2 will cancel out, right? And you end up with x equal minus 1.5, right? Of course, I think what you do normally do is a shortcut where some people say you take the 2 down and you divide and divide, right? And you end up with x equal minus 3 over 2, x equal minus 1.5, right? You do this. And as I said, it's perfectly acceptable, right? Nothing difficult um, there, right? All right, let's take another one. Let's say you have to solve something like this. X over 6 equals to, let's say, a half, right? So in this case, what you can do, you take x over 6 multiply by 6, and you take half multiply by 6, and you get what? Okay. So you can put this over 1, right? You can put it over 1, no problem. You cancel, and you end up with x equal to, well, half of 6 is 3, right? Like that. There is a thing, I heard about cross multiplying before, and some people might do this, right? So you cross multiply like that. So you get 2x equal to 6. X then is equals to, you take down the 2 and divide, right? 6 over 2, x equal 3, right? Same thing. Same thing. What about if you have this now? Wait, let me give you another one. You have something like this. 1 over x equal to, let's say, 3. Have something like that, right? Well, you can take the 1 over x, multiply it by x, which is 3 times x. So you do that to both sides. So you can place this over 1, no problem. You cancel, right? And you end up with 1 equal 3x. Your next step now, divide both sides. Divide both sides by 3. So you get 1 over 3 equal to 3x over 3. These two will cancel out. And you're left with 1/3 equal to x, right? You can write that back as x equal 1/3. No problem. You can leave it like that, no problem. Again, some people, they do it like this. They put 3 over 1, cross multiply. So you get 1 equal 3x. And then you divide, you take that down and divide, you get 1/3 equal to x, right? Perfectly, acceptable. Nobody will tell you anything. Unless you're doing a course that, where what you call the rigor, the mathematical rigor, is strictly required. You do something like this cross multiplication bit. Some mathematicians would frown on something like that. Where you got that from? Cross multiplication is not a mathematical operation. People would say that. But for this course, perfectly okay, acceptable. Good. So let's mix it up now. Let's mix it up. Let's say you have this, you have something like this. 2x plus 1 equal x minus 4. Look at something like that. So you got x on both sides. You got subtraction. You got addition. You got multiplication going on. All manner of things going on in this one, right? So, and here's where the shortcut sometimes is even preferred, right? But we'll do that a little later. So what you want to do is, first of all, maybe you want to get the x's over here, get all the constants over here, and let's see how we'll do that. So we subtract x from both sides. So we got 2x. All right, let me go with minus x right there. minus x plus 1 equal x minus 4, right? So you end up with x plus 1 equal to minus 4, right? And then you want this 1 out of here. So you just, next step, x plus 1 minus 1 equal minus 4 minus 1. So you get, this becomes 0, get x equal minus 5.
Sorry, you could please go over the back.
Okay, 1 second. Let me just, yeah. So, yes, born.
Sorry, you could just please explain the concept step by step than just going into it later, please.
All right, yeah. Yeah. So I was saying you have x on both sides here, right? Both sides of the equation has an x. So one strategy, now that you have to use this one, is to get all the x's on one side and get all the constants on the other side, right? So my strategy is that first you want to get this x out from here. Want to get this x out from here, right? So what we have to do is subtract x from both sides. And that's what I'm doing here. Look here. The 2x, I'm subtracting x from this side, and I'm subtracting x from this side. Everything else remains the same. You get that up to there? My strategy is to get this x out of here, so I subtract x from both sides. When I simplify this piece, I get this x. The 1 comes back there. X minus x, 0, and this minus 4 comes back here. See if you follow, because that's the hardest part. You see how we get this? Give me some feedback.
Yes, sir.
Good. So once we get this, it becomes very simple now. We have to get this 1 out of here because we want x alone. So we subtract 1 from both sides. And that's what we do here. So this is going to become 0. You're left with x alone. Minus 4 minus 1 is minus 5. And that's your answer. Right? Of course, in every simple equation, when you solve it, right? And if you want to know your answer is right, just put back the value here, right? 2 times minus 5 plus 1 will be equal to minus 5 minus 4, right? And is this minus 9 equal minus 9? Right? Good. The shortcut that people use a lot, which is perfectly acceptable, is this. 2x plus 1 equal x minus 4. So people take this x over, and you take this 1 over, right? So this plus sign that is in front here changes, right? Plus to minus. This plus sign plus to minus, right? So you end up with 2x minus x equal minus 1 minus 4. You get x equal minus 5. Perfectly acceptable. It works. So instead of doing all that I did here, in one line you had it solved. Not every time it will happen like that, right? So don't get used to one-liners. All right, let's try another one. Good. So let's try this one. Okay, 5 minus 2 bracket 3. Oh, okay. Let me use an x there. All right, I can have an x afterwards. Let me go with a minus x. Just to make it a little harder. Minus x equal to 2. Good. So what do we do here? Well, one might be tempted to subtract this 2 from the 5. But don't forget that this is a multiplication sign here. And you can't do subtraction before multiplication. So you have to use the distributive law and remove that bracket, right? So you have 5 minus 2 multiplied by 3 is 6, right? 2 multiplied by minus 2 multiplied by 3 is minus 6. Minus 2 by minus x will give us positive 2x, right? Equals to 2. Tell me if you follow up to there, right? So you use the distributive law to remove or to clear away the bracket. You multiply the 2 in front of the bracket by everything inside. Good.
Sir, please go over back for again 6. 2 minus
minus 2 by 3, not 6, yeah. It's minus 6 in fact. So you can now simplify this. 5 minus 6 is minus 1 plus 2x equal 2. And then to get this 1 out of here, you can add 2 to both sides. Add 1 to both sides. So this gets rid of this, right? And you're left with 2x equal to 3, right? And you can now divide both sides by 2, and you get x, okay, this will cancel that, equal to 1.5. Yeah, boy.
Sir, I see we have a minus 1, right? After we get the 5 minus 6 plus 2x equal to 2, then see we get minus 1 plus 2x equal to 2, then see we get minus 1 plus 1. Where the other 1 come from?
This one here, and that one there.
Mm-hmm.
I choose to add 1 to get rid of the minus 1 from there. Remember, I want to
so,
isolate the term with the x.
so
So I
sir,
want to
can I
get
ask
rid
you?
of this minus 1. So I just add 1 here. And once I do it
So,
here and I do it over here, it's perfectly acceptable. What you do to
so
one side, you do to the other side.
we could just add a random number,
We could do that,
like,
yes.
or you add one.
I could
Okay,
add
no
5, I
problem.
could add 10. Once I do it to one side, I must do it to the other side. That's
Okay, no
all.
problem.
Yeah.
Thank you.
Of course, from here, you can use your shortcut. Once you remove the bracket, right? You can do your shortcut now. This is what you could do. You could simply, you have this, right? You could simply take your minus 1 over there and change minus to plus, right? So you get 2x equal 2 plus 1. 2x equal 3. And x then is equal, so you take down this 2 and divide, right? And divide, you have 3 over 2, which is 1.5. You can do that. That's up to you. As I said, the shortcut is acceptable. So I can take it out.
Yes, sir.
then you can have all kinds of variations. You can have fractions now. Let's go with one with a fraction. You have, okay, a quarter x. Let's go with minus 1/3 is equals to, all right, let's go with half x. Plus 1/6. Let's go with something like that. Right? So what do we do here? Well, again, I'm saying there's several approaches, right? This is what some people would do. They would multiply. Some people would get all the x's together, right? And then get all the constants on the other side, right? For me, and I'm going to switch to the shortcut here, right? I'm going to bring this over here, and I'm going to take this over here, right? So I'm going to end up with, okay, I end up with some horrible negatives no matter what. All right, let's work with it, no problem. Let me take the minus the 1/6 where this was, right? So I'll have I wonder if you can handle that. All right, let me go ahead and do it. So I'll have 1/6 minus 1/3 equal to a half x minus a quarter x, right? So this here, I mean, you can mentally do this. This will be minus 1. What would this be? This will be 2/6. You'll get minus 1/6 there, equal to a half x minus a quarter, give you another quarter, right? You all know how I get this minus 1/6 there?
No, sir.
All right.
Yes, sir.
I can treat this here.
Sir, when this 1/6 go over the equal sign, it is supposed to be negative 1/6.
Oh, you're right, you're right. Yeah, negative. Yeah, good observation. I must be sleepy. Yeah. So I'll add the two together, right? And keep the sign. So I'll end up with a minus number here. So, okay. Take the minus outside and put 1/6 plus 1/3, right? So, you do a little LCM business and so, right? So you'd have 1 plus 2, right? So you get a minus a half, would that be it? Equal to a quarter x, right? So you want to get x. So x then will be equal to minus a half divided by a quarter, right? So x then will be equal to minus a half multiplied by 4/1. You all understand how we do that? We flip over the divisor. So then you get 2 1s, 2 2s. So you end up with x equal minus 2.
Sir, question.
Mhm.
How is it you have a quarter there?
Well, half minus a quarter is not a quarter. I didn't do the arithmetic. I thought you'd figure that out. A half minus a quarter is not a quarter. But if you don't like that, we can do that the long way. That's not a problem. So you can factorize out, put a half minus a quarter and put the x outside, right? And then you find your LCM being 4, it'll do the thing. right? So this will turn out to be a quarter x, right? That's how we get that. Y'all don't know a half minus a quarter is a quarter?
Okay.
Yeah. So what I'm trying to show you here is how complicated it can get, right?
But please do one when you group in like terms and then do it like that.
Well, that's what we did here. We put all the x's on one side and all the constants on the other side. Let's try another one. Maybe I'll have one where let's say you have to solve something like this.
Sir, can you please go back? I'm trying to just
Oh,
jot it down.
oh, you want? All right, no problem.
Thank you, sir. You can go ahead.
Okay. Take one more, maybe with let's say you have something like this. 2 bracket x minus 1 equal to 3. Let's go with uh, for the sake of simplicity, let me put a uh, I'll put a 3 over here and a 2 over here. I go 3 here and go 2 here. So look at that, right? So yeah, you can remove your brackets there. You multiply everything in the bracket by what's in front here. You do the same thing over here. So you end up with 3x minus 3 equal to 2x minus 8. Right? It's down there. Okay, I wonder what that is. All right, good, yeah. So now, and I'll go to the shortcut. I'll take this 2x over here, and I'll bring this minus 3 over here, right? So I end up with 3x minus 2x equal to 3 minus 8, right? And 3x minus 2x will give us x. 3 minus 8 will give us minus 5. Right? So the hardest thing was to remove the brackets. And then you try to get the x's on one side and all the constants on the other side. Okay, let's try another one maybe that involve a fraction. let's say you have to solve something like this. X over 5, okay, minus 3 over, let's say 7 equal to 1/5 or something like that, right? And I'll use a different approach now, right? You can carry this minus 3 over 7 over here, yes. And then, add them up and so. Another approach that people use is they find the LCM, of 5 and 7, right? Which is what? 35? 35? And they multiply everything by 30, right? So x over 5, they'll multiply it by 35. Then take the 3/7, multiply by 35 as well. And then take the 1/5 and multiply by 35 as well. Right? So you get 5 1s, 5 7s. So this becomes 7x here. 7 1s, 7 5s, 3 5s, 15. So you get minus 15 equal 5 1s, 5 7s. So you get 70, right? So now this resembles something we know how to solve, right? So we take the 15 over there. It will become positive 15. So you get 7x equal 7 plus 15, which is what? 7x equal, what's that? 22. And then you take the 7 down and you divide. You get x equal 22 divided by 7. X equal 3 and 1/7. They have so many possibilities. But here is where, you have to remember one rule, right? For you to maintain the balance, what do you do to one side, do to the other side. When you do the shortcut way, sometimes you lose track of that, right? The other thing you want to keep in mind is that you try to bring all the x's to one side, right? And you take everything else to the other side. But if you notice, you are making use of all your knowledge of fractions, of all the BODMAS rule, everything comes into play now, right? When you use the shortcut method, you're tempted to, sometimes you forget the whole idea of what you do to one side, you do to the other side, and you can very well mess things up if you're not careful. Good. So we did a lot there on equations. Do you want a little break and then we come back and we tackle inequalities or inequations? Or you want to go through and we finish early? Which one? You tell me.
Sir, we can take a break.
Take a break. All right, we come back at 6:30 then, right?
Thank you.
All right, so let's turn our attention now to simple inequalities. Right? You see some books, I noticed the textbook says inequations, the course outline also said inequations. That's not a problem. So we also call them simple inequalities, right? So how do we solve inequalities, right? So you know what are inequalities, right? You have, okay, x plus 1 is greater than 2, or x minus 1 is less than 3, or sometimes you have an equal sign here, right? X plus 1 is greater than or equal to 2. You read that, or you say x minus 1 is less than or equal to 3, right? So you can see, of course, they can resemble the very types when we were doing equations just now, right? And they can get as complex as them. However, there is a simple rule to solving inequalities. And the rule is this: you solve inequalities the same way you solve equations, except there's one little exception, right? So remember this: you solve inequalities the same way you solve equations. Only exception is this: when you multiply or divide throughout by a negative number, reverse the inequality sign, right? So that's the only exception, really. When you multiply or divide throughout by a negative number, with a comma there, reverse the inequality sign. I'll illustrate with an example or two just now. So that's the only difference, right? So a mosquito is bothering me. Came in the room with me. I opened that door. All right. Yeah. Let me illustrate with a few examples. So as I said, you have an inequality to solve. You know, you want to solve it. Sometimes they also use the word solve. They say, find the range of values of x, you know. Instead of saying that, they may say, find the range of values. They say sometimes for x, or they say the values of x for which. Sometimes they say that, you know, and they'll give you for which, let's say 2x minus 1 is greater than 5. Let's just say that, right? And the reason why they're talking about a range of values, it's not one value that it can take on, right? I'll explain just now. So you solve it just like you treat this just like an equal sign, right? So you take the minus 1 over there, you get 2x is greater than 5 plus 1. So 2x is greater than 6. Divide both sides by 2, or you take down that and divide, you get x is greater than 6 divided by 2, right? So x is greater than 3. Just like you're solving an equation. You pay no mind almost to the inequality sign. And the reason why I said it's a range of values, they say x is greater than 3. So x can be 4, x can be 5, x can be 10, x can be, 3.5, it can be 5.5, any number greater than 3. That's all. You think you get that? You solve the inequality the same way you will solve equations. Now let's apply the exception. Let's take one. Okay, so you want to, let's say, solve 3 minus x is greater than 4. Let's say something like that. So let's say you use the shortcut method and you take the 3 over here, right? So you end up with minus x is greater than 4 minus 3. So you get minus x is greater than 1. But you remember you want to find x and not minus x. So you might want to do this now. You might take minus x, multiply it by minus 1, and you will take the 1 at the end here and multiply it by minus 1. But whenever you do that, you have to reverse. You have to reverse this inequality sign and have it like this now. Right? So here you had a greater than sign. Now you have a less than sign. Minus x by minus 1 gives you x is less than 1 by minus 1 is minus 1. You get that? Once you do that multiplication, you multiply both sides by minus 1, right? You have to reverse the inequality sign. The temptation here is that, okay, you have minus x is greater than 1. And let's say you divide. Sometimes people would say, all right, okay, let's say you treat this as a minus, and you take it down and you divide. You might forget to flip around this, you see? So you have to remember, you have to reverse the inequality sign. Very important. And just to show you why you must reverse the inequality sign, right? Let's just say, all right, you didn't reverse the inequality sign. So your answer will be x is greater than minus 1, right? So let's say, all right, if x is greater than minus 1, say x equals 0. If you were to put 0 here, 3, all right, so that was the original inequality here, right? So I'm going to try x equals 0. So you get 3 minus 0 is greater than 4. That's saying 3 is greater than 4. That is not correct, you see? On the other hand, if you reverse the inequality sign like we said we should, it says now x is less than minus 1. So let's take a number less than minus 1, minus 2. So we have 3 minus minus 2 is greater than 4. Is that true? Of course, because this will be 3 plus 2 is greater than 4. 5 is greater than 4, which is correct. You see? So it makes sense, that rule about reversing the inequality sign. Right? When you divide throughout or when you multiply throughout, by a negative number. Is that clear?
Yes, sir.
Okay, good.
Yes, sir.
So of course you can get complicated and whatnot. As I said, you solve it just like you would solve equations. Just remember that one rule, right? Good. So let's talk briefly about word problems. Word problems. And in particular, we'll talk about word problems. Let me add on leading to simple, let me move this out of the way. Simple equations, right? Good. So I know when it comes to word problems, a lot of people are looking for, just like how when you're solving a simple equation, there are some definite steps that you can follow. As we said, what you do to one side, you do to the other side, and you can never go wrong, right? And you try to isolate all your x's on one side, everything else on the other side. There's some definite, things that you can do, and it always works. Problem with word problems is this. Word problems can come from any field, right? And therefore, your problem is to model the word problem, right? Your task is to model the word problem, right? W-O-R-D, word problem. Mathematically, right? Mathematically. That's your problem. And therefore, your ability to translate a verbal statement, into something mathematical. Yes, Ford.
Hi, sir. Sorry for disturbing the class. Can you please excuse me? I get at that working at the hospital. I get emergency.
Okay,
Currently, right.
yes. Go. The recording will be available. Go.
Okay, sir.
All right. Yeah. So that's your problem. You want to try to model the word problem, right? Well, in the context of simple equation, well, if it can be modeled using a simple equation, right? So one of the things you might want to do is, okay, identify, well, what is it they want you to find, right? And you can give it some kind of name, right? You can say, okay, let's say you want to find out about what can I use? Let's say you're looking for the length of a square, right? You want a dimension of a square. You don't know it, but they're going to give you some information that would lead to you finding the dimension of the square, right? So what you might want to do is let x be the dimension of the square, or it doesn't have to be x. You can use length, you can use L, sorry, to be the dimension. You want to, declare the unknown to be some variable, right? So whatever they want you to find, you declare it to be some variable, X, Y, L, whatever. You choose. At times they will tell you what they want you to declare the variable to be or the unknown to be, right? Again, I want to remind you that this is not an attempt to give you steps, right? Because as I said, these word problems can come from all over the place, and all of them will not be able. You will not be able to solve all of them the same way. But behind all of them, your task is to basically model the problem. That's the first thing you want to do. Model the problem mathematically, and I'm telling you how you can do it. So they start off. You might start off with, giving the unknown a name, right? You can assign a variable X, Y, Z, L, anything to the unknown. Another step you might want to take is, if you can draw a diagram, right? And I put that if possible, because not every question, right, or every problem out there would allow itself to, or lend itself to drawing a diagram. That may not be possible. Sometimes, though, you do have that situation, right? You do, and I'll probably do an example or two to show you where, yes, a diagram is possible. at other times, right? What you'd want to do is what this first part is saying. You would want to connect or connect or relate the variable or unknown to other information given. Right? So the diagram could help you. Sometimes your knowledge of other subject areas and so would come in. So you want to make that connection, connect or relate the variable to other information that is given. And when you have done that, well, then you'd want to solve for the unknown, right? And when you have solved for the unknown, well, then you can answer the question, right? That was raised at the beginning. Think you get an idea what I'm talking about? Let's illustrate all of this with maybe an example, right? Let's use an example. I'll borrow the one that I'll borrow this one from the textbook. Good. You can see this one? So here you have some information given, right? In this one, you don't have to worry about giving the variable a name or the unknown a name. They already give it, right? They call it X. So you don't have to do that. Good. So what you want to see here, you want to model this problem. It so happened that this problem lends itself to a diagram. It's talking about a rectangle. So what the first thing you want to do is maybe sketch a rectangle, right? Sketch a rectangle. And the size of this rectangle, well, are X and 7 cm, right? So I'm not certain which one. Well, you can put X here, you can put 7 here. You can put it the other way around. You could put a 7 here and you could put the X here because you're not certain, right? What will give you an idea though is the extra bit of information. They say that the perimeter is 40 cm. So, okay, this is going to be X as well, and this is going to be 7, right? So they're saying when you add up all these sides, it's equal to 40. That's what perimeter means, distance around. So you're gonna relate or connect all this information, right? You're gonna relate the variable or this unknown to this 40 and use the 7 and so in a single equation. So when you look at this, 2x plus 14 should add up to 40, right? So you are relating the unknown x with all the other information given. So after you have done this now, well, you can solve, right? You solve for x, solve for x, solve for x. So you take the 14 to the other side, so 2x is equals to 40 minus 14, 2x is equals to, what's that, 16? 26. X then is equals to 13, right? Or 26 divided by 2, x equals 13, right? So x then, x is equals to, or x equal 13 cm, x equal 13 cm. So our guess that x is here makes sense because 13 is much bigger than 7. Right? So in this problem, you didn't have to name the unknown. They tell you it's x. It lends itself to a diagram. Right? You could easily connect the unknown with all the other information, and then you solve it, and then you're able to answer the question. At other times, that a diagram may not be possible, and I'll probably give you, let's do an example with that. Can I move this out?
Yes, sir.
All right. I'll borrow another one. And this one doesn't lend itself at all. It doesn't lend itself at all to a diagram as such. Right? So our task here is to model this problem, first of all. We want to model it. But
Sir, can I see the question, please?
I didn't hear that.
Oh, sorry, I'm seeing.
You see it? Yeah. So we got to model this problem. So they're talking about 3 consecutive even numbers whose sum is 42. So they're talking about even numbers. They want 3 of them, right? And these 3 numbers got to be consecutive. So what you can do is, well, you have to give the variable a name, right? Or assign it a name. So what you can do here is let the first of the 3 numbers be n, right? So we're naming the first one, n. Then the second number will be, if the first one is n, and here is where your knowledge of number theory will come in. If the first of the 3 numbers we're talking about is n, what will be the second one? Mathematically, I'm talking about how do you express the next even number? If the first one is n, what will be the next even number? What will be the next even number? How far is the next even number from the previous one? How far apart are even numbers? How much? How far apart are even numbers? 2, 4, 6, 8. How far apart are they? Nobody knows that?
Just a number apart, sir.
They are what?
A number apart.
What do you mean a number apart? What do you mean by that?
They're 2 number apart.
They're two apart. They're 2 apart, right? Good. So the next one will be n plus 2, right? Then the third will be what? The third number will be what? If n is the first one, n plus 2 is the
4?
second. Exactly, n plus 4.
n plus 4.
So the information says these 3 even numbers add up to 42. So you just have to add n plus n plus 2 plus n plus 4 almost add up to 42, right? So now you're relating the unknown to all the information that is given, right? So you can now simplify this, right? N plus n plus n is 3n. 2 plus 4 is 6 equal 42. What do you do now? You solve for n, right? So we're going to do it here. So 3n then is going to be equal to 42 minus 6. 3n then equal, how much is that, boy? 42 minus 6 is what? 36? Is that right? Hmm? So n then is
Yes,
equals to
sir.
36 over 3, which is 12. So you're given n. You have to answer the people's question now, right? So the three consecutive, what am I writing? Getting sleepy myself. Even numbers are n, which is 12, n plus 2, which is 14, n plus 4, which is 16, right? And when you add these up, you see that you do have 42, right? So this problem did not lend itself to a diagram. However, you have to know a little bit of number theory, right? You have to know your numbers. So that's what happens sometimes. And we can go on and on and on, but the basic steps, right? The basic step is what I said. Your overall task is to model the problem mathematically and solve the equation to answer the question. But when a diagram can be drawn, you draw it. When it can be drawn, well, you have to abstractly, translate all the verbal expressions into mathematical relationships and connect them. And when you have connected them, right, well, sometimes they lead to simple equations. They can lead to other more complex equations. But the ones you will be given will be simple equations, right? At least this far in the course. I'll send you some notes. They will have some word problems inside, right? They have some examples as well as some exercises. You can always look them up, right? You can always look them up. Good. So I think we'll pause there because we touched on simple equations, simple inequalities, and then we talked a little about word problems, right? And I think we have done enough work for us to do a little test. So your test number 1 is going to be on Tuesday, right? Same 5:30. All right, let me stop this recording. To be honest,